Hi guys, so today I'm back covering more AP Calculus response questions. So AB exams question 2 was about areas and volumes given two curves. So as usual, part A asks us for the area between the two curves. So luckily we're given the diagram and don't have to draw it out or graph it. Even though we're given a graphing calculator, so we could graph the functions anyway. So let's do some prep work here by doing this. F of x here and g of x. So region R, we could see that it does align. Our bounds would be 0 and 3. So we know that the upper curve is g of x and the lower curve is f of x. So the area would equal the integral from 0 to 3 of g of x minus f of x dx, which would equal 5.137 approximately. Part B is a volume with cross-section problem. So the cross-section is a rectangle with a base of region R and height of x. So the area of the rectangle would be R times x, or x times g of x minus f of x, since that's the height of R at a given x. So to represent the volume, we would need an integral. So let's plug in here. The volume would be the integral from 0 to 3 of x times g of x minus f of x dx, or 7.705. And that's our answer to part B. Part C, in part C, we're only asked for the setup. So it's a volume of revolution around y equals -2. So to give yourself visualization, here is y equals -2. And you're going to rotate the entire solid around this. So to make stuff easier, let's just shift everything up 2. So here's y equals 0. Here's h of x equals f of x plus 2. And j of x equals g of x plus 2. And this is just to visualize stuff. So this will be your new transformed thing. And you're going to revolve this around what's now the x-axis, which makes stuff easier. So how are you going to plug all this in? Remember, you're going to use the washer method. So the volume would be pi times an integral from 0 to 3 still, because you're not changing your left and right bounds, you're only moving up and down, of, and remember the washer method, you're going to square each one individually. Don't square them together, that's for cross sections with their squares. So here is f of x plus 2 squared minus g of x plus 2 squared. And don't forget the differential dx. And look. Wait, let me see this. No, it's g minus f. Yeah, g is upper and f is lower, and now this should be the true setup. So we're going to say washer method. Yeah. So if you see a negative volume, that probably means you switched which one's the upper or the lower curve, or made a mistake somewhere else, especially when you're shifting something. So that's something to be mindful of. You could still fix this on the exam. If you see something negative with volumes, that probably means something's off. So finally, part D, we're moving away from areas and volumes, and we're dealing with parallel tangent lines. So the slope of a tangent line at a point is represented by the derivative. So for the two functions of the same tangent lines, and have the lines be parallel, f prime of x must equal g prime of x. So this means f prime of x equals 2x minus 2 equals x plus sine pi x. So we're going to plug in this function near our calculator and find the zeros. X minus 2 plus, wait, no, we need the derivative, so it's literally given to us, that's fine. 1 plus pi cosine of pi times x. So we're going to subtract the functions, and here we're going to get 2x minus 3 minus pi times cosine pi times x equals 0. And now let's plug this into decimals. 2x minus 3 pi times cosine of pi x. And we need a number from 0 to 1. So let's zoom in here where it's equal to 0. And there we go. It's 0.675. We're going to round that off to 0.676. From 0 less than x equals 1, this is true at x equals 0.676. So that's FRQ 2. It's a pretty straightforward one, especially compared to the tricky first one where you are given two functions. You had to know which one to use for each problem. For area volume questions, the good thing is you're not going to have to explain that much. You're just going to plug and chug with your calculator, especially this is in the calculator section. You didn't have to do any of those manual calculations that could take time and make you make silly mistakes. Yeah, I think that's pretty much it for this problem. So see you guys next time, where I'm going to go over BC2. I know you guys want that parametric particle motion. We got polar this time. But I'm gonna teach you guys how to not be afraid of polar, and solve this one and brave it. Even though we did get unlucky this year with polar, especially after 4 years of parametric.